started looking at this idea of front-end estimation. And you wrote in your notebook why front-end estimation. Read what you wrote. And then tell me, why on earth would I use front-end estimation? Grace, why?
Because it's easier to tell time.
Okay, it's easier. What makes it easier, Grace?
Because if I ask my mom what time is it, she's not going to say, it is 9:40 and then 15 minutes, 70 seconds plus something. It will be good.
Okay, so it's easier because it gets us to that benchmark number, that friendly number, right? Oh, it's about 9:30, not 9:27, 45 seconds, right? Why else would I use front-end estimation? Ethan?
Front-end estimation, I would use it because it could help with 340 plus 660 because you only have to use the hundred.
Okay, so when I use front-end estimation for a 3-digit number, I'm only using the value of that hundreds place. Does this help me add? Is it going to give me an exact number?
No.
No. This is not an addition strategy. It's an estimation strategy, which means a close to number. Emma, why would I use front-end estimation?
Because it makes it easier to say, not say, you're 12 hours, 9 minutes, 2 seconds.
Sure.
It makes it easier.
Gavin, sit up. Yeah, so estimation is used to get to that easy number, that about number. Not a exact number, not a specific number, but one that's close enough. So let's look at the problem that we did last week. If you remember, Mr. Reed wanted to know about how many 3rd and 4th graders there were, so he can start saving up to get treats for them at the end of the year. We decided that we were not going to do regular addition. Why did we decide that we're not going to do regular addition? Adrian?
Because it's
Why are we not going to use regular addition, Braden?
because we have to put in the solution.
It did ask for an estimation, but why did I not just add them all up the first time? Right?
Because we knew there wasn't just going to be like 300, like that much kids, because we knew there was going to be more kids because we had new kids every day.
Yeah, if we do addition today, we're going to have to redo it later. I don't know about you, but I don't want to redo something. I might as well just give an estimate, a close to number, and then I can do the real math at the end. The real addition, that exact number. So we chose to do addition because we know this number of 3rd graders and 4th graders are going to change. We get new students all the time. Students move. That number changes every day. There's no sense in us adding the whole thing. We can just make an estimate. And if you remember when we did front-end estimation, exactly what Easton was saying, we take the value of that first digit in the hundreds place, and that becomes what we add together. So we estimated last time that Mr. Reed needed 300 trees. Give me a thumbs up if you remember that. Great. Great. However, that's still a little vague. Vague means it's too broad. It's too big of a number. Like it's close, but I know there's still a lot of space. Right? That's like saying my house is close to here, but it's still several miles away. Do you see what I'm saying? It's still too big of a number. It's not exact enough. I don't want an exact number, but I want a better close to number. Is there a way that we can still estimate or make a guess, but get closer to the actual number? Dominic?
Maybe use the tens.
That is what we're going to do. So if you didn't hear Dominic, he said maybe use the tens. If we use those tens, it's going to get us to be much closer. This is called rounding. Go ahead and label the next blank page in your notebook. Rounding. Rounding. And then the definition is underneath it that you also need to write in your notebook. Rounding is moving to the nearest benchmark number. It can be within 10 or it can be within 100. We're going to worry about it within 10, and I'll explain what that means in a little bit more. But go ahead, and write down the title and the definition. We've talked about these benchmark numbers before. We even made a list in our notebook. What is a benchmark number? What is a benchmark number? Because if we're going to be rounding to a benchmark number, we need to know what a benchmark number even is. Dominic?
I think it's kind of like when you, so if I have 100 and 50s in the middle, and I go more to the, where 100 is, it's like 25, and then on the right side, there's like 70.
Okay, so Dominic just listed several benchmark numbers. Anyone remember what a benchmark number even is? Emma?
Easy numbers.
They're easy numbers. Easy numbers. That's all a benchmark number is. Specifically, though, almost all benchmark numbers are multiples of 10. Which means when I multiply or I skip count by tens, I can get to an easy number. Just like 10, 20, 100, 200, 250. All of those I can get to by counting by tens, which makes them a benchmark number. They're easy numbers to work with, easy numbers to add. Gavin, you're very far behind. Now, when we round, I can do it to the nearest 10, 120, got some 10s in there, or the nearest 100, 100. Benchmark numbers can be both. Does that make sense? Yes, no, maybe? Yes, no, maybe. So again, once we plotted everything, we figured out that 146 was closest to 150, which means 146 is about 150. We did the third graders. Now we gotta do the fourth graders. Alright, let me check what that number was. Let me revisit my problem. 242. Alright, go ahead and write the number 242. And then draw your number line. Once you have drawn your number line, we need to find the tens digit in our number? What is the tens digit in our number? Braden? 4. Go ahead and underline it. What's going to be my first endpoint on my number line? It's not 242. What is it going to be? Liam?
240.
240. Go ahead and write that. Remember, we are rounding to the nearest 10, which means my number line is 10 numbers long. So what's going to be my end point? Eliana? 250. Very good. What do I do next? What do I do next? Grace, what do I do next? Find my midway point. Find the midway point. What is my midway point? What's going to be that midway point? Braden?
245.
245. We figured that out because we know it's a distance of 10, and half of 10 is 5. And Brinley told us that can just simply go in the ones place. Now that our number line's ready, go ahead and plot 242. Where is that going to go on your number line? Where's it going to go? Adria, where's 242 going to go?
Kind of close to 240.
Yeah, it is going to be kind of close. Is it going to be like right here?
No.
No. A little bit farther out?
Yes.
Yeah, remember 242 is going to have another number in between before we get to 240. We have 241. But I agree, I would put it about there. 240. Which means which number does 242 round to? Which endpoint is the closest to it? Arwen?
240.
240. How far away is 242 from 240? Gavin? 2. So 242 rounds to, or is about, 240. So now that we've rounded these numbers to the nearest 10, let's see if when we add them together, we get a better close to number. So I have 240 fourth graders and 150 third graders. So I'm adding 150 plus 240. If you don't remember how to add this way, you add up your ones column first. 0 ones plus 0 ones gives me how many ones? 0 ones. 5 tens plus 4 tens gives me a total of how many tens? 9 tens. And then 100 plus 2 100s gives me a total of how many hundreds?
300. So 300.
Whoa!
That's a lot.
That's a lot more than 300. It's like almost 100 more.
Almost like
So If I do front end estimation, it's still going to be 300. But 390 is a lot more.
It's almost 400.
So let me ask you this question. Mr. Reed's still not going to just add because we'll have to re-add, and that's a waste of time. But which type of estimation should he use? Should he use rounding or front-end estimation? Remember, front-end estimation gave us the total of 300, and rounding gave us an estimate of 390. Which one do you think he should use? I want you to turn and talk to someone at your table and tell them which strategy he should use and why.
Yeah.